Welcome to Examalist lecture series on basic classical mechanics. So we are continuing our discussion on basic classical mechanics, and in this lecture series I'll talk mostly on Newton's laws of motion. So instead of naming them Newton's laws of motion, what I did is I have just named it as we'll study about all about forces. So what did we learn about force? One thing we know that force is something that has the power to create an acceleration. That is something we already know very well. Now it means force creates motion. So it's a direct consequence. So if force creates acceleration, it means force is responsible for motion. So it is responsible for making objects move. It means the objects will not move if there is no force. Agreed? So for example, if there is an object and if this object is moving in a straight line motion, it means at some point in the past, at some point in the past, there was a force that acted on this object. Agreed? It means some point in the past, there was a force that acted on this object, and this force created motion. So one thing is for sure, that force creates motion. So what can be the reverse? The reverse is, if there is no motion, it means there can be two things. One, there can be no force. Okay, so what are the consequences of no motion? So if there is no motion, then one is there can be chances that there is no force at all. Okay, that you know directly. How? So if you have an object lying on the floor, so let me draw, consider this is the floor, and consider you have an object lying on the floor. If it is not moving, it means one direct thing is there is no force at all. Agreed? And another thing that can also cause no motion is total force is zero. Okay, so force total is zero. So total force zero is also responsible for no motion. So let me explain. So if you have a force along this direction, force on this block, so let this force be 10 Newton. And again in this direction you apply the same force 10 Newton. Will there be any motion recorded in the block? There won't be any motion because the total force is zero. So two things can cause zero motion. First thing is, if there is no force, there won't be any motion. Second thing is, if the total force is zero, then one thing is for sure, that there is no motion. Agreed? Now what we'll do is we will emphasize on this second part. The second part will tell us a lot of things. A lot of things. So consider the example number 1 where we'll use this second part. Agreed? So as we have discussed earlier, that if you have a block on this floor, okay, and if the block is not moving, it means the total force is zero. So it means if there is a force from this side, and say this force is F, okay, then there is another force from this side whose value is same as F, as a result of which there is no motion in X direction. There is no motion in X direction. But then one would naturally think that this object, it has no motion in X direction, it has no motion in the Y direction. You can naturally see there is no motion of this object in the Y direction. And if you still want to use this idea that total force has to be zero, then one thing is for sure, that the force acting downward is the mass, is due to the mass of the block. And if there is no motion, then you are forced naturally to consider a reaction force that the floor gives on the block, and you call it a normal force. So the idea of normal force came from the very concept that if there is no motion, there is no force. It means if there is no motion, then the total force is zero. So the birth of the idea for normal reaction came directly as a consequence of the law that we studied in nature. We saw in nature if the total force is zero, there is no motion. So there is no motion in the x direction. Everything is happy. Everybody is happy because we see that the total force is zero. But we can also see there is no motion in the y or the minus y direction. It means there has to be forces that has balanced each other. One such force was mg, which is quite known to us. We call it weight, and somebody must have balanced this weight, as a result of which there is no y direction motion. That is normal reaction. Let me give you one more example. So this is example number 2. Okay. In example number 2, imagine that you have a rigid surface, say the top, and with on this wall or the top there is a pendulum hanging. There is a pendulum hanging. Now one thing is for sure, if the pendulum is hanging, then there is no motion. It because the pendulum is not moving, it is just hanging from the string. So in nature we know that if there is no motion, then we have to naturally consider that total force is zero. Agreed? Now what are the forces? You already know there is one force mg due to the mass of the ball. This mg acts downward. And now to satisfy this thing that since the ball is not moving in the y or minus y direction, you are literally forced to assume that there is an upward force in the string called as the tension that balances the mass. And why you consider the upward force? Because your law says that if there is no force, if the total force is zero, then there is no motion. So if there is a force mg acting downward, and now you want to consider the total force on the ball is zero, you are bound to define another force called as the tension. And that tension balances the mg, and then you say that, hey, look, total force is zero and there is no motion. So the birth of normal reaction and the birth of tension all came from the fact that the total force has to be zero when there is no motion. This is for sure. Agreed? So once we have studied about the birth of normal reaction force and tension, then one more thing that you might have studied during your plus 2 is the contact force. Okay, for example, consider you have a straight line path. Okay, and upon this straight line path, two objects are moving. Say two blocks are moving. So this is block number 1 and this is block number 2. Agreed? So if these two blocks are moving, then you might have seen that you take a force called as the contact force and you denote it by small f. Agreed? You denote it by small f. And then you draw the free diagram that if on this block there is a big force f acting on this block, and this block and this force is making this entire system of two blocks move with an acceleration a, and and mass of first block is m1 and mass of second block is m2. What do? You say that the force has created an acceleration in this system. So the system is made with the mass m1 and m2, and you are bound to write this equation. But then your teacher tells you that, hey, you have to do this one thing, you have to consider the block separately, and you make a force f acting on it, and then the teacher tells you that you have to also now consider a small f called as the contact force, and then you write F minus F equals to m1a. Agreed? This is what you do. Now question is, why the hell do you consider this free body diagram? Why the hell do you consider this small f? That we will discuss in our next lecture. What literally gave birth to this force called as the so-called the contact force in between the two blocks? Okay, or you can also call it as a normal reaction between the two blocks. What gave birth to this, we'll discuss in the next lecture. And then with the next lecture, our idea of using free body diagram, now from where the free body diagram has come, that will be completely clear. Agreed? One thing is for clear in this lecture, one thing is clear, that you understood from where the normal reaction came. It just came from the necessity that if there is no motion, total force is zero. You learned from where the idea of tension in the string comes. It again came from the necessity that if there is no motion, total force is zero. Now in the next lecture, we'll talk about from where the idea of using normal reaction force between two moving blocks, or you can also say contact force, from where this idea has come. So in the next lecture, we'll talk about it.